In this class I want to talk about something called the perpendicular distance formula and look at applying that to find the perpendicular distance from a point to a line. Just a quick recap of some of the things we've spoken about. We've spoken about different types of equations of the line, different forms. We have the slope-intercept form of the equation of a line, y equals mx plus c, where m represents the slope and c represents the y-intercept. We have the point slope form of the equation of a line, y subtract y1 equals m times x subtract x1, where m represents the slope, and the opposites of these things, x1 comma y1, will be a point, some point on the line. And then finally we had the standard form of the equation of a line, which looks like this: ax plus by plus c equals 0. We'll just ignore that one for this class. Generally we write that where a, b and c are integer form. We usually try to get a being positive. Important to note that negative a over b is the slope of that. So take the negative of the coefficient of x, put it over the coefficient of y, and you have your slope. In this class I want to look at using perpendicular distance formula without deriving it. It's in your formula and tables booklets on your coordinate geometry page. See if you can find it. Try to find that now. And it tells me, how to find the perpendicular distance from some point to some line. So if I have some line and the equation of that line is ax plus by plus c equals 0, and I have some point, let's call it x1 comma y1, well then the shortest distance, the perpendicular distance there, that distance there, that's called the perpendicular distance. Well, that perpendicular distance can be found using this. Notice the absolute value brackets here. So what do? Well, we take our coordinates from our point and we just plug them into the left hand side of this equation, and that goes inside your modulus brackets, and then we divide by the square root of the coefficient of x squared plus the coefficient of y squared. Okay, and that's how we find the perpendicular distance between a point and a line. Let me look at an example here. So it says find the shortest distance between the line y equals negative 3x plus 8 and the point negative 2 comma 4. I'm just going to get rid of this for the moment. So what does the line y equals negative 3x plus 8 look like? Well, I know that it has a slope of negative 3 and it cuts through the y-axis at 8, so it's going to be quite a sharp descending line with a slope of negative 3. That's the line y equals negative 3x plus 8. In order to find the perpendicular distance, I need to express that in standard form, adding 3x, subtracting 8 from both sides. That's the line 3x plus y subtract 8 equals 0. So I just took that line and I expressed it in standard form. Again, that's stuff we've looked at in previous classes. Make sure you know the different forms of the equation of the line. If you don't, go back and check out the videos on those. The point negative 2 comma 4, where would that be in relation to this line? One thing I could do is just see, which side of the line I think it's on. If I plug negative 2 in here for x, I'd get y equals negative 3 times negative 2, 6 plus 8, which is 14. That means somewhere in this line is the point negative 2 comma 14. This is not on the line. Negative 2 comma 14 is somewhere in this line. Well, where is negative 2 comma 4? Same x coordinate, smaller y coordinate. That means it's directly below it. Somewhere down there, 10 units below. So somewhere down there is the point negative 2 comma 4. I can see it's on the left hand side of this line, if you will. Okay, so nice way to check to see where points are in relation to the line. Put it in slope-intercept form, substitute in your x value, see what y value would be on that line, and then compare your point. So an x coordinate of negative 2 on this line would give me a y coordinate of 14, so that we know the point negative 2 comma 14 has to be on this line. The point negative 2 comma 4 is directly below that, 10 units below. This is essentially what my graph looks like. I haven't actually answered the question. It's just to try to get a good picture, and hopefully you can do that reasonably quickly. What I'm going to do is find the shortest distance. What is the shortest distance? Well, the shortest distance is not from negative 2 up here. The shortest distance would be perpendicular to that line. That's the shortest distance between the point and the line, and we call that the perpendicular distance. And we have a formula called the perpendicular distance formula, which says the perpendicular distance is equal to the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. So it really is as simple as just plugging some numbers into a formula. In this case, really straightforward. This is ax plus by plus c equals 0. So now a is 3, b is 1, c is negative 8. And this is the point x1 comma y1. So what do? We take the absolute value on the top and we divide it by a square root on the bottom. What goes into the absolute value? Well, all I do is I take this point, negative 2 comma 4, and I plug it into the standard form, the left-hand side of the standard form of the line. So 3 times the x coordinate, that's going to be 3 times negative 2, plus the y coordinate, plus b times the y coordinate, so plus 1 times 4. B is 1 here in this case, plus c, which is negative 8. And then on the bottom, I'm just taking the square root of the coefficient of x and the coefficient of y. Notice the coefficient of y, of course, is 1. We just generally don't write that coefficient in, so it's 3 squared plus 1 squared. And actually, you could type that straight into your calculator as it's written. No harm to work it out, though, for yourself. That's negative 6 plus 4, which is negative 2. Subtract 8, that's going to be negative 10. The absolute value of negative 10. All over the square root of 3 squared plus 1 squared, that's 10. The absolute value of negative 10 is 10. Absolute value means distance from the origin, distance from 0 for a real number. So negative 10 is 10 units from 0. So we get 10 divided by root 10, which is, of course, root 10 units. So I know the distance from this point to this line is root 10. So the perpendicular distance is root 10 units. I don't know what they are. Maybe they're centimeters, maybe they're meters. Sometimes they'll give you units. If they don't, we'll just write in the word units. Okay, and that's how we find the shortest distance between a line and a point. That formula is in your formula and tables booklets. Make sure you can find it. So it's in your formula and tables booklets. Okay, it's on your coordinate geometry page. Okay, so that's the perpendicular distance formula. Practice some of those problems. Exercise 4.6.